So here's another problem. It says determine the weight W required to keep the system shown in static equilibrium. Okay, so in this case we define like where our forces are acting. Okay, so I'm going to draw a free body diagram first. So the point of interest for this question is right here. Okay, right here, I colored in red. So what's happening at that point is I have a force acting downwards. That's 100 newtons. I also have a force acting up and to the right with some angle 60 degrees. I'm going to call that T. And there's also this other rope up and to the left at some 45-degree angle. Okay, 45 degrees. So all we need to recognize is pulley systems, they don't change forces, they just change the direction of the force acting on. So because this thing is, the rope is looping over the pulley and downwards, this is actually just the W, the weight W. So even though the picture looks more complicated, it simplifies down to this single drawing here where we have this single point, and acting at that point are three forces in different directions. What makes this question a little bit harder is the fact that we have no right angle triangle. So I'll solve this using the algebra method first, and then we will look again at the triangle method. And this time we'll have to use sine law to solve for it because it has no 90-degree angle. So let's look at the sum of the forces in the x direction first. Sum of the force in the x direction, we have 0 newtons is equal to, so we're going to look at our picture, say, let's look at this T force first. We need to find out what is the horizontal component of T. That is just going to be T cos 60 degrees. Okay? So we want to become very proficient at working with these triangles and seeing components. If this is T, this is going to be T cos theta. This is going to be T sine theta. And because this is the adjacent of the angle, the other one is the opposite of the angle. So T cos 60 degrees. And that W is in the to the left direction. So if we define up as positive and right as positive, this is going to be minus W sine 45 degrees. So there is our first equation. Now if we write an equation for the y direction, looking up, that's T sine 60 degrees. You'd be careful though, there's actually two forces in the upwards direction. So both the T and the W are supporting the y direction. So plus W sine 45 degrees. So those are the two forces going upwards, and they are supporting this 100 Newton mass. So this is a little bit trickier because we have two equations, but each equation has two unknowns. But in grade 10, we did learn, or you did learn, different methods to solve a system of linear equations, because that's all this is. So first, I am going to take this equation and simplify it. So I'm going to write down T cos 60 degrees is equal to W sine 45 degrees. And now I can write down T is equal to W sine 45 degrees divided by cos 60 degrees. Now we can use what we call substitution. Substitution. Okay. We're going to substitute this value, this quantity right here. That is the W sine right into this T right here. Okay, so we're going to end up with W sine 45 degrees over cos 60 degrees sine 60 degrees. So again, all we did was say t is now this term. So this term multiplied by sine 60, and you have plus W sine 45 degrees minus 100. Now this looks complicated, but all it is like sine 45 over cos 60 times sine 60. That's just a number. And W sine 45, like sine 45 is just a number. So what this comes out to be, so you go, what is sine 45? And if you want to actually simplify some, you may recognize this trigonometric identity. Sine 60 over cos 60 is tan 60. Yeah, sine 45 times sine 60 divided by cosine 60. We end up with a value of 1.2247 W plus sine 45 is 0.7071 W. And that's all just equal to 100. So 100 divided by the addition of those two numbers. And we end up with a value of 52 newtons. And we're actually done because the question was just asking us what is W. We could go ahead and solve for T if we just now plug in W back into this previous expression. So 52 multiplied by sine 45 divided by cos 60. You can actually just solve for pretty straightforward. T is equal to 73 newtons. Didn't need to solve for that though. I did it anyways. So how do we do the triangle method? So we're going to take these three vectors that we drew at the very beginning and add it using the tip to tail method. So it's just off to the left right here. I have 100 newtons going straight down. T is up and to the right. And W is up and to the left. So I tried my best to approximate those. That's 60 degrees. And that right there is 45 degrees. I know this is 100 newtons, and this is W, and this is T. And I could have drawn it, doesn't matter how I draw it, there's W and T. Right? Order does not matter when drawing these two triangles. So notice how this will give us the same answer as the other one. All that happened was I just kind of rotated it around. We're going to use that first triangle I drew. So before we start, I'm actually going to draw it again right here. So for us to solve a triangle, we need to know at least three things, either three lengths, three angles, or a combination of three angles and lengths. So at first glance, we don't have three, but we can very easily just use what we know about geometry. If this angle is 60, this angle must be 30 degrees. Also, if we use alternate interior, if this angle is 60, we know this is also 60 degrees right here. So inside this larger angle right here, we can see it's 45 plus 60, that is 105 degrees. So we actually know the last angle as well. Well, knew from the beginning, it's 45 degrees. And if you want, you can just confirm that all the angles in a triangle must sum to 180. So go 105 plus 45 plus 30. And indeed, it does sum to 180. So now we can go ahead and solve for W or T. There's W, there's T. So we can go ahead and use the sine law. So we get W over sine 30, W is opposite of 30, is equal to T over sine 45, and that is equal to 100 over sine 105. And put that in newtons there too. So if we're solving for it, we can see that 100 divided by sine 105. And if we multiply by sine 30, we get our answer of 52 newtons once again. Alternatively, if we multiply by sine 45, we'd end up with the answer for T, which is 73 newtons. So regardless, both methods will get us our final answer. Just one is a bit more visual than the other. So one's just using pure algebra, the other one's using more just showing your understanding of how vectors add together. One thing I did mention before is this only works if you have 3 vectors. The question is what happens if you had a situation where we had, I don't know, 4 ropes or 3 ropes. I'm not saying we will, but I say what if we had this situation? Right, this one we cannot use the triangle method. The reason is when we add the tip to tail method, we end up with the mass plus our 3 other lengths. We have 1, 2, 3, 4 ropes. We end up with a shape like that or something, and we can't use any sine law or cosine law to solve for that. Again, this method works when there are 3 cables.